In this video, we are going to develop the first knowledge that the technician needs to master when he begins his specialization in duct systems for air conditioning. Stay with us and remember to subscribe to our channel. There are three fundamental terms that the technician must master very well. These are 1. Air velocity inside the duct. 2. System pressure. 3. Airflow. Air velocity within a duct is the speed with which air moves within the system. The higher the speed of the air, the greater the noise generated by the installation, and the greater the pressure needed to carry the air to all points. The only good thing about having more speed is that less material is going to be spent on the ducts because they are going to be smaller, and also because of this they require less physical space. Now we are going to classify the air conditioning ducts by their speed. To do this, we will take into account three basic categories. Low-velocity ducted air conditioning systems. These systems are characterized by larger duct cross-sectional areas, resulting in air velocities of up to 2,000 feet per minute. These distributions are used in most air conditioning installations because it is quieter, has less friction losses, less fan power, and less air leakage. On the other hand, when we talk about ducted air conditioning systems with medium velocity, we are referring to installations that are characterized by air speeds in the range of 2,000 to 2,500 feet per minute. Now we have high-velocity ducted air conditioning systems. These systems are characterized by smaller duct cross-sectional areas, thus air velocities greater than 2,500 feet per minute. High design speeds result in lower initial costs for the duct manufacturer, but require increased fan effort to get air to all points. That is, higher operating cost for the user. Now let's talk about the pressure of the air conditioning system. The air pressure is the force that it is going to need to be able to overcome the friction of the walls inside the duct and reach all the outlet grills without problem. In this case, we are talking about static pressure. There is also dynamic pressure, which is directly linked to the speed of the air inside the duct. We can affirm that the total air pressure inside a duct is then the sum of the dynamic pressure plus the static one. The fans must provide the air with enough pressure to reach all the vents. The pressure values that a fan handles are very low. For this reason, special units of measurement for pressure are used. These units are usually the water column in meters, inches, or feet. Now we are going to classify the air conditioning ducts by their pressure. Low-pressure air lines. These are systems with pressures less than 3 inches of water column. In general, in these systems, the air velocities inside the ducts are less than 1,500 feet per minute. Medium-pressure air ducts. These are systems with static pressures between 3 to 6 inches of water column. In general, duct velocities are less than or equal to 2,500 feet per minute. High-pressure air ducts. These are systems with pressures between 6 to 10 inches of water column. Static pressure is generally limited to a maximum of 7 inches of water column, and duct velocities are limited to 4,000 feet per minute. Systems requiring pressures greater than 7 inches of water column are normally unwarranted, and could result in very high operating costs. Let us now study the airflow term. The flow rate is the amount of air in volume form that passes through a duct. The most widely used units to measure the airflow of a facility are cubic feet per minute (FM) and cubic meters per hour. As the density of the air changes very little in the duct system, we can say that it is true that the volumetric flow of air that enters the fan of an installation is equal to the sum of the volumetric air flows at the outlets of the rules. One way to relate the flow and the speed of the air is with the formula that says that the area of a duct is equal to the division between the flow of air and its speed. In general, we can say that for every ton of refrigeration handled by the air conditioning system, the fan must supply an airflow of 400 cubic feet per minute. At this moment a link is appearing to a related video, which will surely interest you. We invite you to see it, but before remember to subscribe and leave your like.